Welcome to MRL. This is the second part of study of solid figures. In this part, let us study about cone. A cone is a solid figure. It has two surfaces, a circular base and a curved surface. It has a tip called as the apex or the vertex. Cone is generated when a right angled triangle, which is a plane figure, which is rotated about one of its sides other than the hypotenuse. So remember that a right circular cone is generated when a right angled triangle is rotated about one of its sides other than the hypotenuse. Therefore, the plane figure which generates a circular cone is a right angled triangle. Now a cone has two heights, the vertical height and the slant height. The vertical height is the distance from the apex to the center of the circular base, and the slant height is the distance from the apex to any point on the circumference of the circular base. And the vertical height is represented by h and the slant height is represented by L. Now we also can establish the relation between the vertical height, the slant height and the radius of a cone. So let us understand how. Now if you take the triangle here, L is the slant height, H is the vertical height, R is the radius. Apply the Pythagoras theorem, we get L square is equal to R square plus H square, and it's a very important relation to find one unknown when the other two things are known to us. Now the area of the circular base is a circle and therefore area is pi r square. The curved surface area, to find the curved surface area we have to cut open the cone and spread it, and we get a sector of a circle. And to find when we find the sector of a circle, it is approximately equal to the area of a triangle, half base into height, and therefore half into base into height is equal to the base is the that is the circumference of the circular base of the cone, and that is 2 pi r, and the slant height is L, and therefore we get the curved surface area as pi r L. Now therefore the curved surface area of a cone is pi r L. The total surface area is the area of the base and the curved surface area of the base and curved surface area. The curved surface area is pi r L, the area of the base is pi r square, therefore pi r is common here. Taking L plus r in the bracket, we get the total surface area is pi r in the bracket r plus L. So please remember that. Now the volume of a cone is 1 by 3 pi r square h, 1 by 3 pi r square h. Now please remember that volume of a cone cannot be found out directly because it is not a uniform solid figure. We cannot just multiply the area of the base and height to get the volume. Here we have to go by an indirect method. So for that we have to consider a cylinder of the same height as the cone and the same radius as the cone, and therefore when we fill the cone with water or any material and fill it into the cylinder, pour it into the cylinder, we find that the 1/3 volume of the cylinder is occupied. That means one volume of cone is 1/3 the volume of a cylinder of the same height and radius, and therefore the volume of a cylinder is pi r square h. So 1/3 volume of cylinder is 1 by 3 pi r square h, and 1 by 3 pi r square h is the volume of the cone. So please remember that. Now coming to the next important solid figure, that is the sphere. A sphere is a solid figure. It has got only one surface, and the radius of the sphere is the distance from its center to the surface of the sphere is called as the radius of the sphere. It is denoted by r. The circle or a semicircle, when rotated about its diameter, we get a sphere. Therefore a sphere is generated by a plane figure, that is circle or semicircle, when rotated about its diameter. Now the surface area of a sphere is 4 pi r square, and the volume of a sphere is 4 by 3 pi r cube. Just remember these formulas. If you want to learn how to derive these formulas, then we have to it will be discussed in a separate learning session. So please remember that. Now hemisphere is 1/2 of sphere. Therefore the surface area of a hemisphere is 1/2 of a sphere, and that is what we call it as 2 pi r square. It is 2 pi r square. The area of the circular base is pi r square, and the curved surface area of a hemisphere is 2 pi r square. The total surface area is pi r square plus 2 pi r square, that is 3 pi r square. Again, let me repeat this. One half of a sphere is called a hemisphere. A hemisphere has two surfaces, the curved surface and the curved surface and the circular base. The area of the circular base is pi r square. The area of the curved surface is one half of the surface area of a sphere, that is one half, that means half into 4 pi r square, that is 2 pi r square, and the total surface area is the curved surface area plus the area of the circular base, and that is 2 pi r square plus pi r square, that is 3 pi r square. Therefore, the TSA or the total surface area of a hemisphere is 3 pi r square. The volume of a hemisphere is one half of the volume of a sphere, and that is half into 4 by 3 pi r cube, that is 2 by 3 pi r cube. So please remember this formula is very useful for calculations. Now, hollow cylinder. Now, hollow cylinder is nothing but a pipe. A hollow cylinder has 4 surfaces. It has got the inner curved surface and the outer curved surface, inner curved surface, the outer curved surface, the base ring and the top ring, which we call as the annulus. The base ring and the top ring are congruent rings. Now, the vertical height is the distance from the center of the circular top and the circular base. It is the distance between the centers of the circular ring and the circular and the top ring, circular base ring and the top ring. The area of the base ring is, we already know this, it is pi r square minus r square. We can find out the area of the annulus by taking the area of the bigger circle, subtracting the area of the smaller circle, and that is pi r square minus r square. Area of the top ring is also pi r square minus r square because they are congruent. Now, the inner curved surface area, we know that the inner radius is r, the inner curved surface area is 2 pi rh, the outer curved surface area is 2 pi capital RH, because r is the capital R is the radius of the outer what you call curved surface, and therefore the total surface area of a hollow cylinder is the inner CSA, that is inner curved surface area, the outer curved surface area, the area of the base ring and area of the top ring. And we know that inner CSA is 2 pi RH, the outer CSA is 2 pi capital RH, then the area of the base ring is pi r square minus r square, top ring is pi r square minus r square, and that means the conclusion is the total surface area is 2 pi RH plus 2 pi capital RH plus 2 pi r square minus r square, a very important relation to find out the total surface area of a hollow cylinder. Now, the volume of a hollow cylinder is the area of the base ring into height, and we know that the area of the base ring is pi r square minus r square and height is h. Therefore, the volume is pi r square minus r square into h. Now, very interesting addition of the property here. To find the mass of the material which forms the hollow cylinder, we can find out its volume and multiply by the density of the material. We already know the volume of a hollow cylinder is the area of the base ring into height, that is pi r square minus r square into h, and the density of the material will be known to you. Depending upon the material, the density changes, and therefore when we multiply the volume of the hollow cylinder and by the density of the material, we get the mass of the material. Generally, this is a question asked in many of the examinations on geometry. Now, combination of solid figures. A solid figure can be divided into simpler and common solid figures to find surface area and the volume. Now, we have a solid figure here. It has got a cone and a hemisphere. That means the cone is surmounted on the hemisphere. Now, to find the surface area of this solid figure, we can divide it into two simple solid figures, that is the cone and the hemisphere. So, find out the curved surface area of the cone, find out the curved surface area of the hemisphere, add it, then we get the surface area of the solid figure here. Now, we know that the CSA of cone is pi r l, the CSA of hemisphere is 2 pi r square, the common is pi r here, in the bracket l plus 2r. That gives the formula to find out the surface area of the solid figure. Now, if you want to find the volume of this solid figure, find the volume of the cone, volume of the hemisphere, and add it. And we know that the volume of cone is 1 by 3 pi r square h, and the volume of hemisphere is 2 by 3 pi r cube. Then common is 1 by 3 pi r square, in the bracket is h plus 2r. So many cubic units of units is the volume of the solid figure. Remember that. Now, I have taken one more example here. This is a solid figure. We want to find out the surface area of this solid figure. To find the surface area of the solid figure, then find out the lateral surface area of the cuboid. There are two solid figures here. One is the cuboid, the other one is half the cylinder. So, find the lateral surface area of the cuboid. Lateral surface area of the a cuboid and the total surface area of a cylinder divided by 2, add it, we get the total surface area of this solid figure. Now lateral surface area of a cuboid, already you know that it is pH, the pH, and the total surface area of a cylinder is, you know that it is 2 pi r plus h, half of that, then we get pH plus pi r in the bracket r plus h, and that is how we find out the surface area of a solid figure. Again I'll repeat. To find the surface area of the solid figure, find the lateral surface area of the cuboid and the total surface area of the cylinder divided by 2, add it, we get the surface area of the solid figure. Now to find out the volume of the solid figure, find the volume of the cylinder divided by 2 and also find the volume of the cuboid. To add it up, we get the volume of the solid figure, and we know that that is how we find out the volume of the solid figure. This is what is the procedure. Now the next point of our discussion is the discussions on solid figures like prism, pyramid and so on. We'll be discussing in this in the next part of the study of solid figures. Okay, remember whatever you have learned and scribble it in a book for your future reference. Thank you.